Guys, what I'm going to talk about today is basically colocation data centers. This is basically the infra on which every IT runs. And we are going to talk about a sustainable part of colocation data centers. Uh, it's a small presentation that I will talk through at any point in time. If any one of you has got any questions, please feel free to raise your hands and we'll go from there. Before we start and also before we end, we'll have a couple of questions for you just to make this more interactive. Uh, my first question is, and let me give you a background, colocation data center, the capacity is generally measured in megawatts. This is amount of power that the servers or the devices or the IT storage consumes. Just one quiz question. How much is the size of India colocation industry in terms of number of megawatts? There are many figures that float around, but approximately, people who know the answer, if you can raise your hands, the size of India colocation industry. Yes, sir. 1,000 megawatts, that's one answer. Do we have any other answers? Yes, sir. 600 megawatts is one more answer. Do you have any other? Yes, sir. One at the back. 20 gigawatt. Okay, so we have three answers, 1,000 megawatts, 600 megawatt, and 20 gigawatt. Uh, one last answer. Let's take one last.
737 megawatt.
737. That's very precise. Actually, the number hovers around the 600, 650 mark. So both 600 plus and 700, I would say it's in the right range. So this is the amount of capacity that third-party data centers are supporting when it comes to IT infrastructure. For the sir who answered 600 plus, can we please have a gift for him? Yes. And a clap for you as well, sir. Thank you so much for letting us know. A second related question, when we look at global data center capacity, and by now I think you would have realized that data centers are power hungry because all the equipments that we run, they consume power. Globally, what is the amount of total power that data centers consume? Any guesses? If you don't know the right answer, it's okay to take a guess. There is a gift at the end. Yeah, I think I'll have to do what my teachers used to do in the school. Just pick someone. Yes, sir. Sorry.
So I may not be able to give you the answer exactly in terms of numbers, but percentage-wise, what I understand is 40 to 50% of the expenses go towards the electricity. That's why.
Sorry, sir. The question actually was of the global power that is consumed, the total power on the earth.
Okay.
What percentage of that power is actually consumed by data centers?
20%.
No, that's actually quite a lot.
In any case, I put a guess.
Yes. Any other guesses? Yeah, I can see three hands there. Can we have all the three answers one by one? 2% is one answer. Next. Sorry, so we have 2, 1.5, and 3, and one person in the white shirt. 2 to 3%. How many of us Googled actually? Yes, ma'am. Let's take this last answer. You're raising your hand as well. Yeah. 5 to 6%. Okay, no. Thankfully and unfortunately, we are not that high. But there are various numbers that are being floated around. But the median number that floats is 1.5%. So let's have a round of applause for the 1.5%, sir, and also a gift for him. The intent to mention these two numbers are that there is a lot of power that is being consumed by all this infra. There is some good work that is happening because the 1.5% was exactly 1.5% 10 years back. It is also 1.5% today. So there's a lot of efficiency that is being built in the system despite all the additional progress that we are doing on the processing front. With this background, let me talk about where do data centers sit in today's IT. How are we related to cloud? How are we related to on-prem, colo, and so on? And then we'll talk about what are we doing for sustainability and why is it important. Thank you. So let me start with the first slide. So this is what data centers are. When I talk about colocation, we are talking about four things. One, power in that building will not go down. Second, cooling in that building will be constant. So if you're talking 24 degrees, it will remain 24, maybe 1 or 2 degrees up and down, it will not change. If the power goes down, there would be enough diesel available to run the gensets for 48 hours, which is why generally when any site goes down, it's a big news. So these sites are based on something like this. Third is there is diversity of network, 3 fiber paths, 4 fiber paths, 5 fiber paths, terrestrial, overhead, so that if one network goes down, the second is available. If the second goes down, the third is available. And third is there's a lot of physical security. This essentially is the 5-star hotel for your servers. So that's what we talk about when we are talking colocation data centers. So when we talk about managed hosting services, they can be done on-premises or they can be done in one such facility. Also, when we're talking about cloud, so all the cloud services that we see in India, more than 95% of that capacity is running on colocation data centers. So whether it is a third-party colo for an enterprise like yours, or whether it is cloud service providers, all the leading cloud service providers, they're ultimately hosted in one such colocation data center. So that's where this infra layer sits in the overall IT industry. And as you would have realized, this is primarily core engineering, that is electrical engineering and mechanical engineering, and some level of telecom. But this is where the entire infrastructure sits. Talking about the evolution of industry. So I've been in the industry for 10 years, so I'll talk about the last 10 years only and not beyond that. The industry used to be roughly 200 megawatts. Mostly it was carriers who were trying to expand their telecom services and BFIs. BFIs have always been the early adopters of technology in this domain. The size was 200 odd megawatts, and mostly it were the telecom companies who were providing the services. As years progressed, in around 3 years, two things happened. One is the telecom started carving out their data center business into a separate entity because these entities started growing. For the first time, a multi-megawatt, multi-city deal was closed with a large cloud service provider. And that was actually a point which gave impetus to public cloud concept, at least for the colocation industry, because after that point in time, the second and the third cloud provider started entering into the country and started expanding. At this point, the customers were cloud service providers because they came in, and large Indian conglomerates and large Indian enterprises. The next boost happened around 3 years later, where the new age companies, like e-commerce companies, payment gateways, they started asking for significant capacities to host their own private cloud out of these colocation services. New service providers started entering. So not just the olden telcos or the telcos which are carved out, they came in. New people started entering. And also some people who had huge requirements started building their own data centers. And the last phase where we are right now, we've crossed 600 odd megawatts, and that was the size that we are talking about. The larger customers are planning to build their own data centers, and there are even more options available these days to consume colocation capacities. Now, who is buying this? More of everyone. So while we hear of cloud-first strategies, there are a lot of use cases where it makes sense to have a third-party colocation service. Even if someone is adopting a cloud-first strategy or adopting cloud requirement, the cloud ultimately sits on one such colocation data center in any case. So all of these put together is actually a demand for someone like us. Some use cases for non-cloud can be driven out of the strategy. It could either be to hold sensitive information or sensitive application where you have a better control, where you can point out to a cage that, here is a cage within which my IT service is running. It potentially could be for regulatory requirements. It could be a sensitive government setup. It could also be a setup for a pharma and R&D. It could also be a setup for a media where they don't want to release their content to any cloud or any other place simply because they feel more comfortable wherever they are. Or it could also be some industries where latency is of high sensitivity. It could be algorithmic trading. It could be gaming. Having said that, today what we see is almost all enterprises have some or the other application where they prefer to have it on third-party colocation. These are the various colocation uses. Now, coming back to the part that we are talking about, I'll speak of a typical data center building that would be meant for 24 megawatts. What do we have in this building? It will have a 3.5 meter boundary wall. That's the physical security part of it. It will have floor loading capacity that is thrice as a regular commercial building. It will have large fire detection, fire suppression system, again a part of physical security. But here is where the interesting part comes in, the amount of engineering that goes into it. A typical building will have 20 plus chillers, each of 1.5 megawatt. Each building will have a backup of around 6 lakh liters of diesel to make sure that when power goes down, the building can run for 48 hours. Each building will have 25 to 30 gensets, each more than 2 megawatt. And that is what is required to support 124 megawatt building. And when I say 24 megawatt, that is consumed by the IT equipment. There is power that is used for cooling also, and there is some power which is lost in the systems also. So the measure of this is actually what we call as PUE, power utilization effectiveness efficiency. Given this background, there are a lot of things that we do to make sure our data centers are more efficient and more sustainable. And that is where the 1.5% has more or less remained constant over the last 10 years. Quickly talking about what we do, I come from Princeton Digital Group. I am the managing director for India. We were formed around 5 years back by senior executives moving out of Tata Communications. We currently operate in 5 countries with 20 data centers across India, Indonesia, China, Singapore, and Japan. Uh, we are backed by marquee investors, including Warburg, Ontario, and Mubadala. And what we do is we provide standardized, which means the same specifications, scalable, which means large data centers. So if you bought some capacity today, but you want capacity 5 years down the line, we make sure that there is headroom to grow. And third and most critical is sustainable data center capacities across this region. And we are also expanding beyond these 5 countries. This is what we've done in the last 5 years, but we'll be expanding beyond that too. Coming back to the sustainability framework, what do people like us do to make sure our data centers are sustainable? One is ensure lowest PUE. So for a certain amount of power consumption, least amount of power should be lost into cooling or should be lost into any kind of losses. Uh, some examples of that are, let's say diesel generators are backing up a power. The further you keep the DG set away, there is more power lost in transmission. So what we do is we create a DG stack, we create a regular DC building stack, make sure that there is only 3 or 4 meter distance between the two. So the amount of cable is reduced, the amount of loss is reduced. We also use UPSs which work at more than 96% efficiency. These are some of the initiatives that we take under the first vertical, which is energy efficiency. Second is renewables. And we'll talk a little more about renewables, taking a specific example of Mumbai. So the idea is to reduce carbon-based energy and to increase renewable power. And we actually go to different lengths to make sure that we are increasing the renewable energy quotient for our data centers. Third is certifications, and certifications of all kinds. So there are sustainability related certification. Each geography will have a green building certificate. Most of the certifications evolved to have data center specific categories. In India, it is typically IGBC, which is Indian Green Building Council. It is based on USGBC. So every geography that we enter, we have the highest rating for the local codes from a sustainability standpoint for the building. Then there are non-sustainability certificates also, but the way they help is that they make sure that we are using standard designs for our data centers. We are not doing anything which is non-standard, and at the same time, we are compatible with everyone. That is where something like OCP, which is Open Compute Project, comes into play. And then we have environmental management certificates, which are the ISO certificates. The last vertical is choice of equipment or choice of technology, where again the idea is to buy something which is off the shelf or to get a line of product created that's suitable for data center. Because the moment you try to tweak specification for any product, you lose the efficiency. The key here, or one of the most fundamental things which is seen for a data center is two: power utilization effectiveness, and second is renewable energy. Let me deep dive into renewable energy and share with you how we are trying to make sure that despite the power consumption increasing, we are still trying to minimize the effect on the environment. This is a typical model. Yes, ma'am. Yes. 100%, please.
Certifications. We've considered about the environmental security. What about your business resilience? If there is going to be any disruptions or downtime, how do you ensure it's up in time?
Correct. So there are business continuity certifications which have evolved for data center also. So if I'm not wrong, it's 22302 or something. But exactly. So those are. Oh yeah. So this is the sustainability framework. So that's not included, but ISO 21000, 22000, 27000, 40000. All of these are standard certifications that we do. What I was talking about was sustainability. Thank you, ma'am. So this is a typical framework of what we would do to get renewable energy in a city like Mumbai. So many of you would know that each state in India has a different regulatory framework when it comes to energy. So in a state of Maharashtra, for if you're consuming 100 megawatts, the size of the plant that you can put in, the renewable energy plant, is regulated. It's a function of the 100 megawatts. So what we do is we won't just put a solar power plant because there's a typical curve in which energy is generated. We put mix of wind and solar so that you can maximize the amount of energy that is generated during the year. By doing this, you will be able to replace 25 to 40% of the total energy consumed. The second thing is, at times, excess energy is generated, so you can store this energy somewhere. This can be stored in batteries. It can also be stored in the form of what is called as pumped hydro storage. So when energy is consumed, you take water from lower levels, keep it to higher levels. Whenever you require the energy, you can let the water flow down, and that's how you use water as a pumped storage. By doing this, you might be able to go from something like 40% to anywhere up to 80%, depending upon what's the size, design, and efficiency of the setup. Then the utility. So, for example, MSCB also generates certain power which is green in nature. So you can buy that energy at additional premium, something between 60 to 70 pies per kilowatt. And last is RECs. The first four are actually physical renewable energy units that are generated. The last one is more of renewable energy credit that you can buy from an open market. The regulation around that has seen a lot of changes over the last 5 years, but they are seen to be stabilized. So we actually invest into captive power plants. As we speak, we are actually making an investment of multiples of tens of megawatts into a captive power plant, which will be set up around 300, 400 kilometers away from Mumbai, where wind and solar power will be generated, fed to our data centers, and that's how we increase the green quotient of our data centers. And this is something that some of the other people in the industry are also doing. And we are trying to figure out within the current regulations, how can we increase the green power consumption and thus reduce the overall impact that all the IT in the country is potentially having on the environment. Sorry, it's a quiz time again. Before we go on quiz, I just wanted to check if there are any questions that you may have for me. Yes, ma'am.
Establishing cloud data center across. There is one event I was part of in May, which was a collaboration with our own state's minister, IT minister. Okay, so they are directly, a government is directly getting involved, and they are collaborating with some esteemed organizations to build the data center as a co-location, to ensure we are having a shared model rather than working in a solo type. So how is your model working?
Ma'am, we have also signed MOUs with multiple state governments, including the government of Maharashtra as well. When cloud service providers provide this service, let's say if in Mumbai, without taking name any of the major top cloud service providers, they ideally prefer to have more than one points of presence, and the distance between the points of presence also needs to be significant. So essentially, if there is a flood in one part of the city, it shouldn't affect the other two. Those kind of diversities is what they want to look at. Hence, in principle, having all the Mumbai data centers at one location is not practical. So, which is why there is a constant dialogue between the industry and the regulators to figure out what is the middle way. At the same time, if I'm sharing my 220 kV substation, yeah. At the same time, if I'm sharing my 220 kV substation with many other people, which means that there is a single point of failure as well. So we want to reduce the single points of failure. Yeah. Okay, if no questions, then I'll ask questions. Uh, India has pledged for how many gigawatts of non-fossil energy capacity by 2030? Yeah, I think there was one instant hand raised. Yes, sir. Sorry, there is a gentleman in white shirt. 500. Okay, that's one answer. Do we have any other answers? 13 gigabyte. Okay,
500.
500. Yes, I think the answer is 500, and we have two correct answers. One is gentleman at the back, and second is sir. Thank you so much. Uh, one more question. India has pledged to reach what percentage renewable energy capacity by 2030? Sorry, sir? The answer is 50%. It is what percentages? Sorry, we'll have to miss out on this one. But we have two more questions to go. India has pledged for reduction of total projected carbon emission by how many billion tons? Reducing carbon emission by how many billion tons by 2030? Sorry,
7.
7 is one answer. Yeah. 9. Okay. Any other answers? 12. 7, 9, 12.
45.
How much?
45.
45. Okay. 7, 9, 12, 45. There's one more answer I heard somewhere. Who's saying 1? Yeah, that's the right answer, actually. Thank you. Thank you so much. And last question, and let's have some energy here, guys. Last question. India has pledged to achieve the target of net zero emission. And this is a very key target. By which year?
2070.
Oh, wow. I think whoever shouted the loudest, I think, gets the prize here. 2070. I think someone shouted very well. I think that's this gentleman here. So what we are doing at PDG, right? Some of the things. We are one of the few data center service provider who's publicly announcing the amount of energy that we consume, the amount of renewable energy that we consume, the carbon footprint that we have. And over and above everything else, we've personally taken the pledge to do 100% renewable energy by 2030. We are currently a young company. We are only 5 years old. So we are in the process of doing our own materiality assessment and figuring out our ways of going there. And it becomes more challenging when the setup is spread across multiple countries, but that's what we are committed to. I would also like to let you know that we are coming up with our first data center in Mumbai later this year. We'll be announcing that sometime soon. It's a 48 megawatt facility. And I'll be more than happy if any one of you would want to visit that data center. We'll obviously reach out to each of you and extend a personal invite for that as well. With that, I would like to close my session. If there are any questions, again, maybe I'll just take 10 seconds and continue. Okay. Thank you so much. You've been fantastic audiences. Thank you so much for your time. Cheers.